Welcome everyone. In the last video, we learned that we call these two limits derivatives, and the derivative can also be shown as dy over dx or dfa, which is just another notation for derivative of fa. Show that derivative of any linear function ax plus b is a. We need to use the limits that we learned, right? Let's start with using fx minus fa over x minus a. You can use the other limit. It's not gonna change the answer. Ax plus b or minus, what is fa? A plus b. This is over x minus a, and of course there's a limit. I can see that I can cancel the b's. Inside the limit, let's take the numerator under the a parentheses, x minus a over x minus a. Cancel the x minus a's out. So therefore, derivative of fx is equal to a. Fx is given to us. What is derivative of it? Let's use the other notation now. Since we are working with x instead of a, let's write fx plus h minus fx over h. We could do the algebra inside the limit, but I want to do it outside because I think that way it's easier. 2 times x plus h squared minus 3x plus h plus 5. Let's see, 2 times x squared plus 2xh plus h squared minus 3x minus 3h plus 5. And this is equal to 2x squared plus 2x, I need to multiply it with 2, so 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 5. Right? Looks correct? Yes, alright. Minus fx. Let's write fx here. Let's write negative fx here because we can just add the functions then. Negative 2x squared plus 3x, negative 5. I can cancel these out. What else can we do? Cancel these out. Cancel these out. So for my numerator, limit h approach to 0, I just solved fx plus h minus fx here. Or let's take it under the h parentheses as well. So 4x plus 2h minus 3. And this is over h. Cancel the h's out. Plug the 0 in. So 4x minus 3. So derivative of fx is equal to 4x minus 3. This was the solution of our second problem. I is closed interval 0, 1, and f is from I to R a function, x squared is given. Can we differentiate f? What is derivative of f0 and derivative of f1? Of course, we will start with the limit again. Let's use fx minus fa over x minus a, which transforms this limit into x squared minus a squared over x minus a. Difference of squares, what was it? X minus a times x plus a, right? So we can write this as x minus a times x plus a over x minus a. Cancel these out. 2a. Derivative of fa is equal to 2a. Now what is 0? For a equal to 0, we can clearly see that 2 times 0 is 0. It's really easy from now on, right? 1, 2 times 1 gives us 2. So therefore, this is our answer. Fx is given to us as x times absolute value of x. What is f derivative 0? Derivative of f0? Limit, again, let's use the limit definition. Fx minus fa over x minus a. Our a is 0 here, so x approaches to 0. fx is x times absolute value of x minus 0 times absolute value of 0, and this is over x minus 0. This is 0, this part is x, so this will be x approach to 0, x times absolute value of x over x. I can cancel the x out. What is limit of absolute value as x approach to 0? It's 0, so we found the derivative of the function at 0 as 0. Last question, right? Yes. Fx is given to us as root x. Find the derivative of n. State the domain of f derivative. Okay, let's use the other definition now. Fa plus h minus fa over h. Let's use x for instead of a actually, because we are working with as x. X plus h. Let's write it here because we will need space. Root x plus h minus root x. This is over h. Of course, I need to multiply this with the reverse sum sign of it, x plus h plus root x over x plus h plus root x. This transforms into x plus h minus x over h times root x plus h plus root x. From here, these cancel each other. I can cancel the h and h. Now I can plug this in, and I get 1 over 2 root x. My derivative is 1 over 2 root x. What was the question? Okay, we found the derivative and the domain of the f derivative. So first of all, we have two conditions for the domain of this function, right? First condition is x has to be greater than 0, greater or equal to than 0. Second condition is my denominator, 2 root x, should not be equal to 0. From here, I know that for x, I cannot pick 0 because that will make my denominator 0. And other than that, every number greater than 0 is fine. So therefore, domain is from 0 to infinity.